Okay, so we're going to try this again, and maybe this time it'll work. So with exercise 202, we're going back to basics. We're going to work just in flat 2 dimensions for today. You do, however, need to save the file that we work on today, because next class, when you come back next Monday, we're going to make it in 3-dimensional. And so I'm going to show you that process, and I'll teach you a few specific commands related to that. I also will apologize in advance the fact that my screen is squished and all funky because the projector has had issues all day. So it is what it is. Hopefully that'll be fixed next week as well. So I'm going to go ahead and open up Rhino, as you guys have just done when the computer was frozen. And on the little tabs that come up here, these are recents from last year on this account. But I'm going to go to New, and I'm going to choose this Large Objects Inches. That sets up the workspace rather nicely for the kinds of things we're going to be making. So I'll pick that. If you don't do it, it's not the end of the world, except that you need to make sure that your units are set to inches. So if you use the default and it's in millimeters or something, we need to make sure we convert that over, and that is in inches. Remember, we can check to make sure that that is in inches by looking down here at the bottom, and it should say inches, which is what we're after. Okay? Last class, I gave you a file to start working with. Today, you're just creating a file from scratch. Okay? Rhino is pretty good about auto-saving and crash dumping if it should happen to crash along the way. Some programs are better than others at doing that. Rhino tends to be pretty good, but it's not a bad idea to at least save it so that it knows where to save the temporary files and stuff. So I'm going to go ahead, before we do anything else, I'm going to go ahead and save this so we can keep saving. So I'll go to File and then Save, and I'm going to go into today's demonstrations here. For you guys, it'll be your exercise files. Under exercise 202, I will call this, this is A136, 202. And I'll go ahead and save it. And that way, I have it as a saved file. It's always a good idea to start with that. It's going to be better recovery if you have saved it somewhere at some point. Okay? So the other thing is that we're going to start today not drawing in the 3-dimensional view, although you will learn over time that drawing flat 2-dimensional stuff in a 3D view isn't that bad. But we're going to work, instead of in perspective view like we did last class, we're going to work in our just our top view. So I'm going to double click on the perspective little tab here, which is going to take us back, maybe not. There we go. And I'm going to double click on the top view so that I'm working in the top view. And at this point, I'm going to start drawing, but I'm not sure where my whole scene is. There it is over there. If I'm looking for the origin and I can't find it by scrolling in and scrolling out, I can type Z for zoom, followed by A for all, or E for extents. We will get to S for selected before too long as well. So I could say zoom A for all, and it'll recenter my work such that my workspace is in the center. You could also do selected or whatever. So I'm going to go ahead and we'll go extents. Perfect. I'm going to zoom in here a little bit. And what I'm looking at is an arbitrary grid that has been set up for me in Rhino. Same thing happens in AutoCAD where it sets up a grid. The grid means absolutely nothing for the stuff that we're doing. So if you don't like the grid, you can turn the grid off. It's in the options. I tend to leave it on. When we get to something called a C-plane, it really helps to have the grid on because you get a sense for what plane you're drawing in. But for right now, it's fine. We'll just leave it there. It is important to talk about how Rhino works a little bit and how drawing works in Rhino, just so that you have some background information. This is very similar to AutoCAD, so if you've worked in AutoCAD, all of this is repetition. If you took 135 with me, I talked about the exact same stuff in AutoCAD, so you're going to get, replication here. But it is what it is. So Rhino is what's called a NURBS modeling program. And in all honesty, I don't remember what NURBS stands for. But essentially what it means is everything in Rhino is defined by math equations. It's defined by coordinates, and it's defined by an equation. So when you create a curve in Rhino, some arbitrary curve, it defines that mathematically, and it's only the curve. Surfaces in Rhino are a collection of, here's one curve, here's another curve, and I stretch a surface between, or something like that. There is no such thing in Rhino as a solid object. It fakes solid objects, so we could create a cube, for example, and it would look like a solid object, and it would feel like a solid object, and it might even call it a solids. Notice we have a menu item for solid, but it isn't in fact a solid object. It's still hollow inside. It's surfaces that go around the outside. When we get to 3D printing, we're going to have to deal with how do you make a solid object out of these Rhino files, and there's some tricks for how to do that, and I'll talk you through that when we get there. But everything is defined fundamentally as math. And so when we start working at the very base level of Rhino, it's nice to think of it in old math terms, in old algebra terms, and that sort of thing. And if you remember way back to when you took like beginning algebra, you had like functions that defined a slope and a line and that sort of thing, and you would graph it on a piece of graph paper. You guys remember this probably vaguely. Okay? Rhino works very much the same way. The good news is we don't have to know any of the equations or the slope or anything like that, but Rhino itself deals with all of those for us. When I look at this grid, it looks very much like that graph that we used to have to draw in math class. And so we can use that to our advantage. The connection between the red line here and the green line here is the origin. That is point 0, 0, or 0, 0, 0 if we're adding in the third dimension. For today, we're just doing 2 dimensions, so it doesn't matter. But that is point 0, 0 on the graph. Positive numbers go up the x-axis, or the red line here. Positive numbers go up the green axis, going vertically here. Negative y's would be going down. Negative x's would be going in this direction. And we can use that to our advantage as we start to interact with Rhino. So what I want you to do first is we're going to go ahead and choose the Polyline tool, which is right below the arrow tool on the left side. We're going to choose that Polyline tool, and Polyline tool is an important tool because essentially it's a line, and then you can create a point and then continue the line somewhere else. It is no different than a line, which just has a start point and an end point. The difference is these are connected together. Okay? So we're going to start using this math frame of mind and coordinate system. We're going to start our point at 0, 0. Now, you might say, oh, well, I can get accurate. I'll zoom in here a little bit, and I'll just put my mouse over it, and I'll start at 0, 0. But if we zoom in, the further in we zoom, the more we realize it's really not at 0, 0. And if I said, OK, well, but now I'm really zoomed in, so I could get right on top of it here, and I could do that. But, oh, wait, we zoom in a little bit more, and at some level, it's always off. So instead of doing it that way, we're going to zoom back out here a bit. I'm going to use that Polyline tool. And if you look at your command line, it says start of polyline, colon, and there's a cursor. So I can actually type in a value here. So I'm going to type in 0, 0, and hit the Enter key on the keyboard. That means that no matter how far I zoom in, that point is always going to be right at 0, 0. Okay? So if I knew at this point that I wanted a line that was 24 feet long going up the y-axis here, I could type the next coordinate of what that line would be. And so the good news for you is on this little handout here, I have these coordinates, so you can basically follow along, so you don't have to do the math yourself. I should point out as well that when I do these little handouts and when I do things on the website, specifically in Rhino, when I type a command, it shows up in a little typewriter font in bold. So you can always tell that I'm typing something versus telling you to do something. Does that make sense? So it's a way of me telling you that this is a typed command. So I'm going to go ahead and type in 0, comma, and then 24 followed by the apostrophe, which is feet. And so it's 0, comma, 24 feet. I'll hit Enter, and I now have a line that is 24 feet long going up in the y direction. So this point right here is point 0, comma, 24. Makes sense. Okay? So now if I wanted to do the next point, if I wanted it to be over 12 and up 24, remember this is all registered based on 0, 0. If I wanted that next piece to be 12 feet over, it would be 12 feet, comma, 24 feet. And I'd go ahead and hit Enter. And that gives me that leg. And I could continue, obviously, with that same coordinate system. Now, this is really good and really easy if you're referencing point 0, 0 or 0, comma 0. But if you're not on 0, 0, or don't have a reference for where 0, 0 is, it really isn't helpful. Unless you're like really good at math and can figure out where all these points are in space or something. I can't. So in comes another opportunity and another way of inputting information. So if I want right here to go down 6 feet, okay, I can type what's called a relative coordinate. So relative to the last point that I clicked, which is right here, relative to that point, I can say I want it to be at. We use the at sign for relative coordinates. In this case, it would be 0 in the x direction and negative 6 feet in the y direction, because I'm going down by 6 feet. So it's at sign 0, comma, negative 6 feet. And I would go ahead and hit enter. And that would then create a line that goes 6 feet down from my last point. If I wanted to go 12 feet over from this particular point, I would say at. This time I'm going 12 feet positive x, so 12 feet, comma, I'm going nowhere in the y direction, so it would be comma 0. And I'll go ahead and hit enter, and now I've gone over 12 feet. So the relative coordinate can be extremely useful relative to your last point. Yeah? If it stopped at a different place or something, Control Z in Rhino will undo the last thing that you did. It leaves the command active, so I'm still in my polyline, but I can undo within the command, which is really convenient. Okay? So let me go ahead and do it again. So this was at 12 feet, comma 0. I'll hit enter. That gets me over there. Now I'll go straight down here. I wanted to go at 0, comma negative 12 feet, because I'm going down. Enter. There it is. Now I could come back here. Now I could switch in my head, and I could go back to an absolute coordinate, like the first ones that I was doing, in which case this point would be x12 followed by 6 up. So it would be just 12 feet, comma 6 feet. So it's no longer relative to the last coordinate. It's relative to the origin, and I could get that point. And then I could say back to relative coordinate at 0, comma, negative 6 feet. Enter. There I am. And when I get done, I either want to snap. Remember, I have my persistent object snaps down here at the bottom. If you don't have those, you'll want to go up to your tools, object snap, and turn on persistent OSnap dialog. And I want to make sure that I snap to that very end point. The other option, if we look up here at our command line, is I can go ahead and close by right there by typing C for close, and it'll close the shape. So I could type C followed by enter, and it closes the shape. Either way, snap to the end or type C for close. So now I end up with this shape, which is the base of this little house room thing that I'm drawing, which, by the way, is on the back of the sheet for reference. Okay? If you guys were in 135, this should look really familiar, right? Right? We did the same thing in AutoCAD. But it's still a good way of kind of working through the kinks and how this particular software works. Now, doing those relative coordinates is certainly fine, but it does take a little bit of thinking power. And there will be times when you're modeling, and I have some things set up that you'll be doing where you'll have to use these absolute and relative coordinates. For right now, if I was drawing this, however, it's a lot easier to do a distance and a direction. So if I started at a random point over here, we'll say right there, and I wanted to go up 24 feet, I can put my mouse in that direction, and I can just type 24 feet followed by enter, and I now get a line that's 24 feet long. And you can see that that 24-foot segment is black right now, but see that I also get a white extension coming off of it. Essentially, what Rhino is asking me is what direction do I want that 24-foot line going? So I have to click one more time in the direction that I want it going. So it's 24 feet in that direction. Then I wanted this at 12 feet, so I'll type 12 feet, and I want it in that direction. I want this at 6 feet, and I want it in that direction. Notice I don't have to use negatives here. 12 feet in that direction, 12 feet in that direction, 12 feet in that direction, 6 feet in this direction, C for close, and I now have the same shape. So compared to typing in all those coordinates, this is certainly a faster way of drawing. If, however, we were trying to do a specific angle, sometimes the absolute or the relative coordinates would be a lot easier to specify than to try to do a distance and a length. It's just another way of interacting with Rhino, and I like to introduce that as a concept as well. So that's a distance and a length strategy. So I'm going to go ahead and get rid of that second one that I created because I really only need one. So now I'm going to move down to another command, and this is essentially what we're trying to do is to create the inner line of this wall. So right now I have the outer line of the wall. I want to create a second line inside. And to do that, I'm going to use the offset command. And this is available under the curve command here. And I can choose offset and then offset curve. So it's available through that menu structure. I can also type offset. So in the command line here, I can type offset and hit enter. Now, there's probably a pretty good chance that if I were to go into the curve tools here, one of these means offset somewhere. The truth is I never actually have used that. Okay? But it is probably available somewhere in the tools for you to use. But for my case, I just typed offset, and that's fine. And here, under distance, I want to specify the distance that I want offset. So before I actually click on anything, I'm going to look at my command line and see what the options are. So the first thing is distance, and I have it set at 5.5 inches right now. I'm going to round to 6 inches, though technically 2x4s, 5.5. That's what blueprint reading's for, right? Little issues, right? If you put siding on the outside and you put sheetrock on the inside, the wall gets fatter, that kind of stuff. Yeah? It's a great question. You do not have to put the quotation mark for inches because we specified our default unit as inches. So it will always assume, because it says that we're in inches down here, it will always assume that if I type a number, it's in inches. We specify the foot marks because the foot mark is not our default unit. So I've specified 6 there for distance. I want my corner to be sharp. If I wanted it to be something different, if I wanted it to have a radius or something, I could change that. Through point, we're not going to worry about. Tolerance of 0.01, that's plenty precise for us. Notice there is also an option for both sides. So if I wanted to offset one line both directions at once, I could do that. I'll show you that in a little bit. Okay? We're going to leave it in C-plane. We're not going to worry about capping it. So our distance is set. Now if we look down here at the drawing, you can see that it's asking me which side of the existing line do I want to have the new line on. So in this case, I want it to be the inside, so I move my mouse to the inside and I click. And it then creates the second line for me. So let me go ahead and do that again in a repeat process. So I've selected the curve that I want to offset. I've gone to curve, curve from object, or excuse me, curve, offset, offset curve. There it is. My distance is set at 6, and I want it to go inside right there. Okay? Remember, I could type offset instead. Either way is perfectly fine. Okay? So now that I've done offset at 6 inches, now I need to add some doors and windows. So if you flip over your page, you can see that I've set up some kind of basic windows and that sort of thing. You do not today need to do any dimensions. So the dimensions are on there for you guys as reference so you understand how big I'm saying these things should be. I'm not expecting you to do the dimensions at all. And actually, I think one of the things that Rhino fails miserably at is things like dimensions. So Rhino's great for modeling, not so much for production drawings. Okay? If I were doing production drawings, I'd do some modeling in Rhino. I'd take those into something else. AutoCAD would be a logical choice. Illustrator would be a logical choice. And we'd go from there. Okay? So now that I have this, I'm going to start with the door on the very top in the center here. And I need to figure out how am I going to draw the door in this location. So the first thing is, if I was trying to specify where the door is, I could add up, okay, 1'6" plus 2 feet plus 1 feet. That would be 4'6" from this wall, and I could draw over where the door is. The other option, though, because I know that the door is centered on the wall, is I could start with a polyline, and I could draw a line that goes from the midpoint of the top to the midpoint of the bottom. Notice down here in my persistent object snap, I do have midpoint checked. I also have endpoint checked, and I also have perpendicular checked. Now, personally, I have point and not checked. That was from something I was doing not related to what you're doing. Yeah. If you don't have these down below, you'll need to go to Tools, Object Snap, Persistent OSNAP Dialog. And then it'll show up for you. So once again, Tools, Object Snap, Persistent OSNAP Dialog. So once that's on, I do want to make sure that end, mid, and perpendicular are checked. There will be points in the semester where you'll need other snaps to be turned on. The one that I want to caution you about the most is near. Near has uses occasionally, but if you leave near on, it will more likely screw you up than help you out. So leave near off for the most part. OK, so I'm going to draw that line like I was talking about from the midpoint of the top here to the midpoint of the bottom there. Remember, it's a polyline, so it will continue on. I want it to end, so I'll hit Enter to end. And now I have one line in the center of this wall for right now. So if I look at the back of the sheet and I see that the door is 3 feet wide, I need a line for each side of the door. Half of 3 feet would be 1'6". Okay? So in doing that, it's pretty easy. I can offset this using the same strategy that we just did by 1'6" and 1'6". So let's go through and do that. So let me go to my curve, offset, offset curve. In this case, I didn't have my curve selected yet, so it's saying please select the curve. I'll select it. I'm going to change my distance to be 1'6". And in this case, I tend to put inches in. I don't think I have to, though. I'm just thinking, you asked the question, so I'm thinking about, I think I usually do, but I'm going to try it without just to see if it does it. So I type 1' for the foot, followed by 6, and we'll see if it does it. Yes, it does it. So it recognizes that. Notice that it converts 1'6" into 18 inches, so it does the math for you. So you could type in 18 inches, or you could type in 1'6". Either way is fine. So I now have it at 1'6". So I could very easily say, yep, I want one in that side, and then I'm going to repeat the command and go to curve, offset, offset curve. Let me select it, and I want to go on that side. There we go. I could do that. But I could also save myself a step. Oops, sorry about that. This one. And when I do the offset, I'm going to type offset this time. I have my distance already set. There's my curve. But this time, I'm going to choose right here both sides. And when I choose both sides, it's going to offset both of them at the same time. So it's more efficient. It's fewer clicks to get that. It doesn't really matter, but it's something that is noticeably different in a production setting. Okay? So now that I have this line and this line established, I'm going to go ahead and select this center line. And while we're talking about selection, I want to point this out for those of you that haven't worked in AutoCAD before. There are two different ways of selecting in both AutoCAD and in Rhino. And that is if you select starting on the left side and go to the right side. So in this case, upper left to lower right. Anything that is completely contained within the square that I'm creating will be selected. So only that line is going to be selected. That's the only thing that was completely contained. If, however, I go from upper right to lower left, same square, same size, it will select that line, but also anything that the square touches, which includes the two walls. So it's important to get used to which direction you select. So one direction from left to right is going to give you anything that's completely contained within. From right to left, we'll get anything that is intersected or touched by the square. Okay? So I'm going to select from left to right, just this center piece, and I'll press the delete key on the keyboard to get rid of it, because I don't need it. Now I need to get rid of this line segment and that line segment, because this is a door. So I'm going to use the trim command to get rid of these two line segments. So I'll either type in trim, or I'll go to Edit, followed by Trim. There is a keyboard shortcut, Control-T, or you can type Trim. So there's 4 different ways of getting to trim. Okay? So I'll select Trim. It's going to ask me to select the cutting objects. These are the two things that are doing the cutting. I need this line and this line. I could click on the first one, hold down Shift, click on the second one, or I could select a box from left to right that completely contains both objects. Now I have those two set. When I'm done, I'll press enter, like it says. Then I can go ahead and select the object to trim. That essentially means click on the spot that you want to go away. So I want this to go away and that to go away. When I'm done, I'll press enter, and now I've finished. Okay? The other thing that Rhino will do, and this will be useful later on, I promise, is that when you're doing a trim, I've selected these objects, enter. I don't have to click on them individually. I can go from right to left, and anything that it's intersected will be selected and it'll go away. So I can trim multiple things at once. For something like this, it makes no difference. It's 2 clicks versus 1 click, not a big deal. If I had hundreds of lines running across one edge and I needed to trim them all at once, then it makes a difference instead of clicking them. So now that I'm done with that little cutout here, I'll press enter to finish. This line and these lines are still separate pieces. So I'd really like them to come together as if it were one continuous polyline. So I'm going to go ahead and from right to left select all of it and then type join and enter. Or I could go up to edit and then join. It's also available under the edit menu right there under join. And essentially that's taking these two little pieces and joining them into the wall at large. Okay, so if I click on it now, it's all completely a wall. Because of what we're going to do in 3 dimensions down the road, next class, it's important for you to keep these as one continuous polyline. It will build into 3 dimensions much easier than if you have separate pieces. And I'll explain that when we get there, but I'm telling you that now as well. So now I have the door cut out, but I need to create the window markers. Now the windows aren't cut out because they're above where the floor is. Okay? So I need to cut out where those windows are going to go, or show where those windows are going to go. So the first one is at 1'6" over from this corner. So this isn't in the middle anymore. It's an awkward place. So I have to figure out how to go 1'6" over. And the temptation for you, especially in the beginning, will be, okay, I'll take the polyline, and I'll go here, and I'll go 1'6" over in that direction, and I'll go down. I'm using perpendicular snap. There it is. I've got my line. Perfect. Looks like a window. The problem is you drew a line that's in an L shape. So you end up with this extra segment of line. And when we go to make it 3-dimensional, when we extrude these, that's going to be a problematic little line. So we need to get rid of it. So I could explode it. I could select it. And I could delete it. But that's a lot of steps. It's a little chunky. So instead, Rhino has something that works great, and it's called Smart Tracking. And it should be on. You should have Smart Track on or in bold down at the bottom. And what Smart Tracking does is it allows you to specify, I want to start a specific distance from another object. So Smart Tracking should be on by default, but I'm going to show you how to use it right now. So what I'll do is I'll take my cursor after I've picked the Polyline tool, and I'll hover. I'm not clicking or anything. I'll hover over this corner. And when I do that, you see how my cursor changes and I get a little white dot that shows up. And that dot kind of sticks there. Okay? Now, if I move my mouse over, the white dot turns blue and I get a horizontal line. When I have this horizontal line, now's the time to type in the distance. So this would be 1'6". I have not clicked yet. I'll type enter. And that then starts my line at 1'6" over from that original white dot. And so I'll snap down perpendicular, and I've created just that line. So I could repeat the process. Here's my polyline. This time it would be from this point. There it is. I'll move over. Okay. Sometimes you get mistakes. So see, in that case, I have an extra little dot there. That's going to make my line not work so well. Right? You can get rid of those points by moving off and then coming back and going away. Sometimes you just get so many of them that it's not working. Hit escape, start over. So I'll be there. I'll move over. There we go. And now I want to type in 2 feet, which is the width of the window. There it is. And now I can draw that line straight down there as well. So it takes some practice with this Smart Tracking to get used to it. but I want you today to practice with it because it will be very, very useful as we go forward. Okay? So I now have that piece in place. I need the center of the window here, so we'll draw a little bit of glass from here to there. If I do nothing else, that's reasonable. In a real plan, we might draw both sides of the glass to make it a little bit nicer looking. Likewise, I think on this plan I have little sills drawn and whatever. You don't have to draw that. We're just trying to get the basics out there. Okay? Absolutely. So let me do the whole window again. How's that? Okay, so I'm going to do this whole window again. I'm going to start with my Polyline tool right here, same tool we've been using. And I'm going to use smart tracking by hovering over this corner and setting that white point. It turns white. Then I'm moving my mouse to the right. My white point turns blue, and I now get a white horizontal line. I will then type the distance from the corner that I want. So it would be 1 foot 6 inches, enter. There it is. I have perpendicular snap turned on, so I can just snap to the bottom of the wall there. If not, I could type in 6 inches, either way. I'll repeat the process for the other side. Polyline, set my point, turns white, move to the right, turns blue, type in the value, 2 feet, enter. There it is. I'll go to perpendicular, right there as well. Enter to finish. Now I have both sides of that particular window. Next thing I'll do is draw the line that goes in the center of the window. It's just a midpoint snap to a midpoint snap. If I wanted to have a little depth to that, I could offset this line one more time. So offset my distance this time, I don't know, might be 5/16 of an inch. I want it B for both sides. There. And we'll get rid of that original. Something like that. Again, not something you have to do. I'm just trying to show you how you can extend this relatively easily. The other thing that I should point out on something like that is when I just did that, I paid a lot of attention to the order in which I selected certain objects. And it doesn't matter. You guys aren't advanced enough to really notice this just yet. But Rhino does certain things that help you out. Like it keeps objects selected as we go. So I have this center selected. Then I do my offset. My distance is already set. I want it B for both sides. I click. It creates the 2 new lines. Notice it didn't deselect the first line. So I can very easily at this point, because it's still selected, press the delete key to get rid of the original lines, or the original line. So I get the 2 that I wanted, can easily delete the other with fewer keystrokes. So now that I have that window established here, I'd like it to be on this side. So I'm going to select it by going left to right so that the whole object is contained. And then I'm going to use the mirror command. I can get to that from transform, mirror, or I could type mirror. And it's going to ask me for the start of the mirror plane. The reason it's asking for the mirror plane is because we're a 3-dimensional modeling program. We need to think of it as 3 dimensions. So instead of mirroring across a line, we're mirroring across a planar surface. So in this case, we can think of it as a line. I'm going to use the midpoint of the bottom here. And I'll specify the end of the mirror plane here. And you see it gives us a little preview for where that's going to happen. And now I have that window copied there as well. Makes life easy. Now I want the window to appear at the bottom here. So I will select this one. I'll use mirror again. I'll go to transform mirror, or I'll type mirror. And this time I'm going to mirror it from the midpoint of this wall so that I get the window at the bottom. There it is. Now I'd like this whole window to be copied over, but I want it to be 6 inches in between the 2 windows. Okay, so here's another opportunity to use our smart tracking. So watch this one. I'll select this like that. I'm going to use the copy command. Now it's important to recognize there are actually 2 copies in Rhino. Same thing in AutoCAD. There's a copy to the clipboard as if you're going to copy it out of Rhino. And there's a copy within Rhino with a base point. The 2 copies are available in different menus. The first one is available in Transform Copy. That's the one we're going to use. If we wanted to copy it outside of Rhino to some other drawing program, we'd be using Edit Copy. or Control C. So it's important to distinguish that there are two very different copies. The one we want is our standard transform copy. There is no Control C. It's just a command. You can type copy. If you just type copy, that will be it. So I'll select copy, point to copy from. Now if I want this window to be 6 inches away from this window, if I use smart tracking here, I can do it all in one step. So I'll set a point, a white point right there on the edge of the window. I'll move this direction by 6 inches. Enter. Now when I snap to that corner, my two windows are exactly 6 inches apart. So instead of doing it with a mirror, drop, move, 6 inches, all that stuff, I've done it all at once using that smart tracking. So let me do that again for you. So I'll select this window. I'm going to go to Transform, Copy, or just type Copy. I'll move and set a white point, a smart tracking point right there at the corner of that window. I'll go over by 6 inches. And then I'll drop this one to right there. And I end up with the two windows that are 6 inches apart. Okay. The other thing is I had a window that was drawn right over here on the side. And I could go back and assume that it's 1'6" from the corner, and I could do the same thing with smart tracking. Okay, here we go. Right there, we'll go up 1'6", and then I could draw that line, etc. But I can also use mirror in a different way. So normally we think of mirror as here's a line, one side reflects on the other side. Okay? But I don't have to have it as a vertical or a horizontal. In this case, I could take this window, again, from left to right. I could go to Transform and Mirror, but instead of picking a horizontal or a vertical line, I'm going to pick a diagonal line that goes across this corner. So I'll go from this endpoint to that endpoint, and lo and behold, it mirrors from one side to the other side on my window. So I've saved myself a bunch of time and effort because I just copied and mirrored. Makes life really easy to do that. Okay? So that's an advanced strategy, certainly. It improves your speed, but whenever possible, I mean, you guys are in your first day of Rhino, I like to try to impart these kinds of things, because if you get that into your head about this is the most efficient way of modeling, you'll be faster. You'll be able to create stuff better, and you'll spend more time on the other things that matter. Okay? So I have those two drawn. At this point, I'm going to continue drawing the rest of over here. I have another set of walls to draw in. If I were drawing those walls in, right, I draw from there to there. I'd also draw. Now here's another use of smart tracking. I set my smart track point there. As I move down, it will. No, it's not snapping for me. Let me set a point there. See how I have those 2 points? Point and point. The two white lines intersect. Now I can start my line at the intersection of those 2 points. So I'm referencing those two existing. Oops. So there, where they intersect, boom, I've got that point. I need to do a little trim. So we'll type trim. Select object to trim. Oops. Hold on. I had something selected. Trim. Select cutting objects. I'm just going to select everything in here. And we'll get rid of that piece. And that piece. Perfect. I have to cut my little hole through this wall, etc. You guys get the idea. It's more repetition of the same stuff. The point today is to get practice drawing. And so if you add more stuff or if you change the locations of the windows, it doesn't make any difference to me. I just want you to practice, and that's the important thing. A couple more, though. If I'm doing my door right here, I'll use the rectangle corner-to-corner tool that's available here. And when I do it, here's a perfect opportunity for those relative coordinates that I was talking about. So if I know the dimensions of the door, I can use those relative coordinates. So let's use the @ sign. The thickness of an exterior door is 1 3/4, 1.75 inches. If you didn't know that, it doesn't matter. Okay? It's not something you need to know for right now, I'm telling you. So I'm going to say at negative, because I want to go to the left, 1.75, comma, it's a 3-foot door, so I'm going to go negative 3 feet because it's going down. Negative 3 feet, and I'll hit enter, and I've now created that door. So in drawing, perfect opportunity to use it. Could I have drawn it starting at this point, 3 feet, 1.75, 3 feet, 1 close? Sure. Just a different way. I get the same result. Depends on how your brain works and what you're thinking of. So the last thing that I need to draw relating to this door is the swing of the door, the arc that represents where the door goes. I'm going to do that using a curve. But if I pick the default curve here, it's going to be really challenging. So instead of that one, I'm going to click the little triangle underneath the arc, and I'm going to pick this one here, which is arc start, end, and direction at start. So I'll click that one, and then I'll click on, it says start of arc, would be right there. End of arc would be right there. And direction is essentially, do I want it this way or do I want it this way? So in this case, I want it this way, and we'll draw it. Really easy. Start, end, direction for that curve. OK, so what I'm going to do at this point is I'm going to turn you loose and let you draw the rest of this. There's a few other commands that might be worth playing around with. Fillet and chamfer are fun because you can create radiuses if you wanted. Chamfers create diagonals. You're more than welcome to play around with those. We'll cover those a little bit more, certainly in 3 dimensions as we go forward. But I like to throw those out there as other options for you. I'm looking for essentially what you see on the back of this. There are things without dimensions, like the little kitchen counter thing. It's 2 feet. Do you have to draw it at 2 feet? It's not the end of the world, right? Again, today is about practice, not about precision. Okay, I want you to have the practice. I want you to get familiar and comfortable with this, because I promise you right now this is the easiest thing that you're doing in Rhino. Right? Everything from here will get more complicated. I do want you to save this. Remember, we already started by saving it in the beginning, but before you're done today, you need to go to File and then Save. Make sure it goes on your flash drive or in your OneDrive folder so you can get it back next class. Absolutely critical that you have this next class, otherwise you're going to have to do all this over again. Okay? So I want to make sure that that happens. The other thing is you need something to post. This, if we were to go render this, would show up with nothing because there's no surfaces whatsoever. So we can't actually render anything. So instead, I'm going to have you go to this little triangle next to where it says top. And when you click on that, I want you to come down to where it says capture and then capture to file. Some of you did this last class with your little cubes. But if you haven't done it before, this is what you're going to do. This will allow you to save a JPEG version of what we've been working on. The JPEG version of this is not something you can go back and edit. It's not the Rhino file, right? It's just what you post. And that's important for you to understand. So you're posting the JPEG. You're keeping the 3DM Rhino file so that you can open it next class. Question? OK, so the curve one more time. Let me do it again. I've drawn the door. I need to create the curve. Instead of using the traditional arc that's available here, I'm going to click the little triangle to see all of the arc tools. And I'm going to pick this third one over, which is arc start, end, and direction at start. You could pick the direction at end, too. It doesn't matter. It's the same curve. And I'm going to go to start here, end here. And then the direction is just whether you want the curve facing out or facing in. If you turn on ortho at the bottom here, it'll snap to being a square. There you go, like that. OK? So if you finish this rather quickly, make sure you post it. Feel free to embellish it. This will end up being a 3D model next class. So if you change it or make it more complicated or adjust the sides or whatever, you're just going to add that into the 3D model later on, which is fun too. OK? One more question. Yeah? The mirror on the, to repeat here, for this window, the mirror is, we select this window, we go up to transform mirror, and then we click on this corner and that corner, and it mirrors across the line in the corner.
And the same thing for the other one whenever I'm trying
To go across the corner, yes.
bring it this way horizontally, it feeds 3 windows together.
The which?
This one to offset them by 6 inches.
So for this window, this one, we're going to select it here. I'm going to copy it. You could go to transform copy. I'm going to go 6 inches away right here, 6 inches. And then I'm going to click right there and hit enter, and that creates the second one. Okay? So I'm going to save this. I'll stop the recording, and then I'll come around and make sure that everybody's working. Do make sure you signed in on the assigned seat list, so you're in your specific seat. If you finish early today, I recognize that today's the kind of a day where some people are going to breeze through this and some people are going to struggle through it. That's normal. If you finish early, you still probably don't have anything else to do, so I'm not going to make you sit here. All right? Starting next week, you'll start to have work for other classes that you can do and stick around. Okay? But you're free to go today after you make your post.